Good day, everyone. Welcome to our General Mathematics class. I am Ma'am Catherine Rose Dianga, Mathematics teacher at San Roque National High School. I am here to assist you in learning the lessons of the List Learn competencies in General Mathematics. Let us learn and enjoy. Our lesson for today is about composition of functions. What you need to know. At the end of the lesson, the learners will be able to perform composition of functions. Let us review finding the value of the given expression given a certain value for x. Number 1. Find the value of the given expression when x is equal to 3. The given expression is x minus 15. Since x is equal to 3, replace x to 3 in the expression, then subtract 15. So this will become 3 minus 15. 3 minus 15 is negative 12. Number 2. Find the value of the given expression when x is equal to negative 2. The given expression is 2x plus 9. Since x is equal to negative 2, first we have to substitute x to negative 2 in the expression. So this will become 2 times negative 2, we replace x to negative 2 plus 9. 2 times negative 2 is negative 4 plus 9. So the answer will be positive 5. Number 3. Find the value of the given expression when x is equal to 5. The expression given is x squared plus 4x minus 10. Since x is equal to 5, we will replace all x to 5 in the expression. This will become 5 squared plus 4 times 5 minus 10. 5 squared is 25. 4 times 5 is 20. So we have plus 20 minus 10. 25 plus 20 is 45. Minus 10 is 35. Number 4. Find the value of the given expression when x is equal to 0. The given expression is 3x cubed minus 6. Since x is equal to 0, substitute x to 0 in the expression first. So this will become 3, replace x to 0. So we have 0 cubed minus 6. Next, 0 cubed is equal to 0. So this is 3 times 0 minus 6. 3 times 0 is 0 minus 6 is negative 6. What's new? When two functions are given, combine the two functions in such a way that the output of one function will become the input of the other. This is composition of functions. Let's have an example. If f of x is equal to 3x minus 1 and g of x is equal to x cubed plus 2, then what is f of g of 3? First, let's evaluate g of 3. Take note that g of x is equal to x cubed plus 2. And since x is equal to 3, we will substitute x to 3. This will become g of 3 is equal to 3 cubed plus 2. Evaluate 3 cubed. 3 cubed is equal to 3 times 3 times 3, which is equal to 27. G of 3 now will be equal to 27 plus 2. So G of 3 is equal to 27 plus 2 is 29. Since G of 3 is equal to 29, then f of G of 3 is equal to f of 29. Now let us evaluate f of x. Note that f of x is equal to 3x minus 1. Let us substitute x to 29. This will become f of 29 is equal to 3 times 29 minus 1. F of 29 is equal to 3 times 29 is 87 minus 1. F of 29 is equal to 86. Therefore, f of G of 3 is equal to 86. Composition of functions, we will find the function that takes 3 directly to 86. To do this, we must compose functions and find f of g of x. Definition. Let f and g be functions. The composition of the function f with g is denoted by f circle of g and is defined by the equation f circle g of x is equal to f of g of x. Let's have some examples. Let's have number 1. F circle of g of x is equal to f of g of x. The first step is to replace g of x with x squared minus 3. So this will become equal to f of x squared minus 3. Next, we will replace f of x to 3x minus 4, where x is equal to x squared minus 3. So this will become equal to 3 multiplied by x squared minus 3 minus 4. Let us apply distributive property of multiplication. So we have 3 times x squared is 3x squared. 3 times negative 3 is negative 9 minus 4. Let us now combine like terms. We can combine negative 9 and negative 4. So f circle of g of x is equal to 3x squared. Negative 9 minus 4 is negative 13. So this will be the final answer. Let us solve this in another way. F circle of g of x is equal to f of g of x. The value of g of x here will be replaced to all the x in f of x. Take note that the value of f of x is 3x minus 4. Then, all x here will be replaced to the value of g of x, which is x squared minus 3. So this one will become 3. Instead of writing x, we will write x squared minus 3. So we have the quantity x squared minus 3. Then we continue with the value of f of x, which is minus 4. Then we apply distributive property of multiplication. So this will become 3 times x squared is 3x squared. 3 times negative 3 is negative 9 minus 4. Then we will combine like terms. We can combine negative 9 and negative 4. So the value of f circle g of x is equal to 3x squared. Negative 9 minus 4 is negative 13. So this will be the final answer. As you can see, the answers are the same. Number 2, g circle of f of x is equal to g of f of x. First, we will replace f of x with 3x minus 4. So this becomes g of 3x minus 4. Next step, we will replace g of x with x squared minus 3, where x is equal to 3x minus 4. So we have 3x minus 4 squared minus 3. Next, let us square the binomial. To square a binomial, the first step is to square the first term. 3x times 3x is 9x squared. To get the middle term, we have to multiply the first and the second term, and then multiply it by 2. So 3x times negative 4 is negative 12x times 2 is the negative 24x. To get the last term, we square the second term of the binomial. Negative 4 times negative 4 is positive 16 minus 3. Next, let us combine like terms. We can combine positive 16 and negative 3. So the final answer will be g circle of f of x is equal to 9x squared minus 24x. Positive 16 minus 3 is positive 13. So this will be our final answer. Let us solve this in another way. G circle of f of x is equal to g of f of x. This one, as you can see, is different or the opposite of the previous example. In here, the value of f of x will be replaced to all the x in g. Take note that the value of g of x is x squared minus 3. The x here will be replaced by the value of f of x, which is 3x minus 4. So this one will become, so x is 3x minus 4. So we have the quantity 3x minus 4. Then we continue with g of x. So we have the square of x minus 3. Let us get the square of 3x minus 4, which is 9x squared minus 24x plus 16. This one was discussed a while ago, minus 3. Then let us combine like terms. We have positive 16 and negative 3. So the value of g circle f of x is equal to 9x squared minus 24x. Positive 16 minus 3 is positive 13. So this will be the final answer. As you can see, the answer is the same as the previous answer. Number 3, f circle of g of negative 2 is equal to f of g of negative 2. The first step is to replace g of x with x squared minus 3, where x is equal to negative 2. So this will be equal to f of the quantity negative 2 squared minus 3. Next, let us evaluate this part of the function. Take note that the square of negative 2 is equal to negative 2 multiplied by negative 2 is equal to positive 4. So this will be equal to f of, this is positive 4 minus 3 is positive 1. Next, let us replace f of x with 3x minus 4, where x is equal to 1. So we have 3, x becomes positive 1, minus 4. 3 times 1 is 3, minus 4. So the final answer will be f circle of g of negative 2 is equal to 3 minus 4 is negative 1. This will be our final answer. Let us solve this in another way. F circle of g of negative 2 is equal to f of g of negative 2. The value of g of x in this example will be replaced to all the x in f of x. We have to take note that all x in g of x will be changed to negative 2. So this will become the square of negative 2 minus 3. So let us replace this as, so we start with f, and don't forget to replace x to this one. So we have 3 multiplied by the quantity, the square of negative 2 minus 3, then proceed to f minus 4. This one will be equal to 3. The square of negative 2 is positive 4, minus 3 is positive 1, minus 4. Positive 3 times positive 1 is positive 3, minus 4. So the value of f circle of g of negative 2 is equal to 3 minus 4 is negative 1. So this will be our final answer. And obviously, this one is the same as the previous solution. Number 4, g circle of f of 5 is equal to g of f of 5. The first step is to replace f of x with 3x minus 4, where x is equal to 5. So this will be equal to g of the quantity 3 multiplied by 5 minus 4. Let us evaluate this part of the function first. 3 times 5 is 15. 15 minus 4 is 11. So we have g of 11. Next, let us replace g of x with x squared minus 3, where x is equal to 11. So this will be equal to 11 squared minus 3. 11 squared is 121 minus 3. Therefore, our final answer will be g circle of f of 5 is equal to 118. Let us solve this in another way. G circle of f of 5 is equal to g of f of 5. The value of f of x here will be replaced to all the x in g of x. But we have to take note that all x in f of x will be changed to positive 5. So the x in f of x will be changed to positive 5. So this will become 3 times 5 minus 4. And the x in g of x will be replaced by the value of f of x. So this will be equal to the quantity 3 times 5 minus 4, then proceed to g of x squared minus 3. Next, let us evaluate this part. So 3 times 5 is 15, minus 4 is 11. So we have 11 squared minus 3. 11 squared is 121, minus 3 is 118. So this will be the value of g circle of f of 5. As you can see, this one is the same as our previous answer. What you need to remember. Definition. Let f and g be functions. The composition of the function f with g is denoted by f circle of g and is defined by the equation f circle of g of x is equal to f of g of x.
Thank you everyone for watching this video. Truly, learning mathematics is fun. See you in our next video. Have a good day!